Good morning to all. So now we have to start with exercise 8.4. In that we have to use the identities already I have shared with you in previous lecture. So before that, as I told, I will take you back to exercise 8.3. That part is deleted. But somewhere if we need from the application point of view, so I will make you understand what is the meaning of those complementary angles in terms of all 60 ratios. So here you can see these are the points which you can remember. If you are expressing sine 90 minus theta, this angle is there, sine 90 minus theta. So result will always be equal to cos theta. And cos 90 minus theta will be equal to sine theta. So sine will get converted into cos and cos into sine. Then secant 90 minus theta will be equal to cosecant theta. And cosecant 90 minus theta will be equal to secant theta. Be careful. And tangent 90 minus theta is equal to cot theta, and cot 90 minus theta is equal to tangent. Means I can express sine in terms of cos, cos in terms of sine, secant in terms of cosecant, cosecant in terms of secant, and tangent in terms of cotangent, and cotangent in terms of tangent in terms of their complementary angles. Now let us understand how to do this, and that will make clarification of the question number 3, first part of your exercise 8.4 also. It is there you have to evaluate sine square 63 plus sine square 27 upon cos square 17 plus cos square 73. The question is evaluate. This is the third question, first part I am taking first of your exercise 8.4, which is directly in connection with your 8.3. So still there is a doubt if applications of those complementary angles will not be the part of your examination, so then we need not to do this question. But at the other end, okay, from the understanding point of view, let us see, this is not that much difficult. So if you want to calculate this, I have taken the numerator first, sine square 63 plus sine square 27. What you can do in step number 1, you can check these both angles are complementary of each other. 27 is the complementary of 63 and vice versa. So decision is yours, whether you will like to convert this in terms of cos or this in terms of cos. Suppose I have taken this. So if sine square 63 can be written as sine square 90 minus 27. If you want to convert this, then 27 can be expressed as 90 minus 63. That you have to decide only. So I picked up sine square 63. So I expressed sine square 90 minus 27 because the complementary of this is lying here only. Now, as I said that sine 90 minus theta is equal to cos theta, so sine square 90 minus theta will also be equal to cos square theta. Then sine square 90 minus 27 becomes what? Cos square 27. So, if we put this back to this number 1, sine square 63 plus sine square 27, so what happens? Sine square 90 minus 27, that is sine square 63 I have taken. So sine square 63 I can express as cos square 27. Sine square 90 minus 27 is what? 63. What is that coming equal to? Cos square 27. So then sine square 63 I can express as cos square 27. So then I have written here cos square 27 plus sine square 27. Now cos square 27 plus sine square 27 will be equal to 1. Because that also I shared with you the first conditional identity, which is a part of your this exercise. That is your exercise 8.4. Sine square theta plus cos square theta is equal to 1. So please understand, theta here 27, again it is 27, that should be common. So it is cos square, it is sine square. So cos square theta plus sine square theta. So theta must be same for both, is always equal to 1. Similarly, if you check the denominator, 17 and 73 again are the complementary of each other. So I have expressed cos square 17 in terms of its complement 90 minus 73. And I said ki cos 90 minus theta is equal to what? Sin theta. So cos square 90 minus theta will be equal to sin square theta. So cos square 90 minus 73 will be equal to what? Sin square 73. and already there it is cos square 73. Again I am back to sin square theta plus cos square theta. So that is equal to what? 1. So now sin square 63 plus sin square 27 I got here, it is equal to 1, and here also sin square 73 plus cos square 73. This is cos square 17 plus cos square 73 I got is equal to what? 1. So 1 upon 1 is equal to 1. So 1 will be the answer for your first part of question number 3. Then second part also is based upon your complementary angles property. So that is sin 25 into cos 65, cos 25 into sin 65. And you check nicely, 25 and 65 both are the complementary of each other. Here also and here also. So what should be the target? You know, if I will convert this cos into sin, sin into sin will become sin square. And if I will convert this sin into cos, so cos into cos will become cos square. Either you convert this in terms of cos, then it will be cos square theta, and then sin square theta. So either cos square theta or sin square theta. Options are open with you. So as I convert this cos 65 in terms of its complementary. So complementary nowhere else I have to look. Here it is line. So sin 25. So and then cos 65 can be expressed as what? 90 minus 25. And cos 90 minus 25 is equal to what? Sin 25, sin theta. Cos 90 minus theta is equal to sin theta. So sin 25, sin 25, sin into sin square 25. Here it is cos, so I have converted this sin into cos. So sin I have expressed 65 as 90 minus 25. So sin 90 minus 25 will be equal to cos 25. So cos 25 into cos 25 will become what? Cos square 25. So sin square 25 plus cos square 25 again is coming in the form of what? Sin square theta plus cos square theta. And again that is equal to what? 1. So then this answer again will be equal to 1. So sin 25 cos 25 plus cos 25 sin 25 sin 65 is equal to 1. Then you will start with the fourth question. First part is, it is given MCQ type, what is 9 secant square a minus 9 tangent square a? So 9 as I can take common, pay attention to that part. As much as simplifications can be done, please go for that. And then keep a watch upon your chapter, what you are doing. You are there in the application of what? Conditional identities, standard conditional identities. So 9 into I am getting secant square a minus tangent square a. And I told when I discussed those 3 standard results with you, I know that secant square a minus tangent square a is equal to what? 1. So then it can be directly replaced by 1, and 9 into 1 is equal to 9. So 9 is the correct option for the answer. That is the B part is the correct option. So in that way you have to do. Then if second part you see, now the option is given 1 plus tangent theta plus secant theta into 1 plus cot theta minus cosec theta is equal to the round of 4 options. Again you have to choose the correct option here. Now it is not that much easy now. You have to see the conditional identity. You have to approach for that, but how we have to proceed? So simple thing, as I started with sin and cos, I told you once you are clear with sin and cos, you can look for all the derivation. So my opinion or my advice to you, if nothing you can do, because step marking is always there in the CBSE, what you can do is you can convert this tangent in terms of sin and cos. That I did here. Similarly, secant I am getting back into cos. Here cot is reciprocal of tangent. If it is sin upon cos, it will be cos upon sin. And cosecant is the reciprocal of sin, so I have written 1 upon sin. Now here within this bracket, if I take the LCM, so that is cos theta, and I am getting the numerator as cos theta plus sin theta plus 1. And in that part also, if we are taking the LCM, that is sin theta, and it will be sin theta plus cos theta minus 1. So that much is clear with me. Once I am back to sin and cos, and then the properties of integers, how to take the LCM and all, you go for that. Now again, you see, it is a trinomial, but somewhere this is cos plus sin, and here also I am getting cos plus sin. So cumulative property says that A plus B is always equal to B plus A. Here it is plus 1 and here it is minus 1. So now again I can see, if you are that much visionary, if I club these two and I have written here as A and this plus sign is there and then I am expressing this 1 as B. So A is cos plus sign here also and here also cos plus sign. B is 1 here and here also. So that means point to discuss is my numerator somewhere is lying in the form of A plus B and here it is lying in the form of A minus B. So directly I can approach that identity here. What is that? A plus B into A minus B is equal to A square minus B square. And LCM cos into sin will make it cos theta sin theta. So A square minus B square. Now cos theta plus sin theta whole square is equal to what? A square plus B square plus 2AB minus 1 square is what? 1 and denominator as it is. Now this is the identity I am using, cos square theta plus sin square theta. You know that is equal to what? 1. So this is plus 1 and this is minus 1. I can cancel these two. So cancel 1 and minus 1, you are left with 2 cos theta sin theta upon again it is cos theta sin theta. So again you can cancel these two. So you are left with 2. So 2 is the correct answer. So that means is somewhere we have to that much alert about the previous knowledge part also. So you can have the idea within the solution of these 2-3 parts what I have taken today to make you people understand how to proceed in this exercise. So simultaneously you have to keep the identities also in your mind, and that is the difficult part students they are finding, especially from the algebra point of view, how to apply and how to identify. So only the answer from my side is practice makes a man perfect. As you people will keep on practicing these such questions, so definitely you are going to become perfect one. So remaining part I will be taking in the next class. I think that much dose is sufficient for today's class. Have a nice time.